Here we go. We've got proportion and ratio problems, right? Out of 250 coins, 50 are mint condition. What's the ratio of mint condition coins to the total number of coins? Well, you can see that they want a ratio, okay? So because of that, you want to pay very close attention as to how they describe this ratio. This ratio wants mint condition to what? Total number. So I need this idea of mint to total. Well, how many mint coins did we have? 50 are mint condition, so let's put that right there. We'll make a fraction. The total was 250. That's great. That's a pretty good ratio, but remember, we treat ratios pretty much like they're fractions, and we should simplify it, right? So divide both of them, top and bottom, by 50, and we should get a ratio of 1 to 5. That's our ratio, 1 to 5. Number 2, the ratio of boys to girls in the ninth grade is 6 to 5. If there are 185 girls in the class, how many boys are there? All right, so the ratio of boys to girls relates to the 6 to 5. So I'll put 6 and 5 here. I know that because it says boys to girls, that this first number needs to be boys and the second one needs to be girls. So let's go ahead and label our proportion just like this, so we'll know that the top row refers to boys and the bottom row refers to girls. Now, I'm going to set up a proportion over here, and I'm going to take the rest of the information they give us. If there are 185 girls in the class, how many boys are there? Well, that how many means I don't know how many boys. So this whole top row is boys. This X is what's missing. I do know that there's 185 girls, and the whole bottom row should be girls. There's 5 girls here, 185 girls there. We've got the proportion set up, so 6 times 185. So 6 times 185 is 1,110. Let me just kind of show you that we're always trying to multiply the diagonal numbers from each other. And now that leftover number, the 5, we're just going to divide 1,110 by 5, and we get 222. So how many boys are there? 222 boys. Number 3, 46 out of the total 310 seniors graduated with honors. What's the ratio of seniors graduating with honors to the total number of seniors? It's a really easy one. We just want a ratio. It tells us right there what is the ratio of, well, how many seniors graduated with honors? Well, 46 did. So I'll just put 46 right here. Put my colon there. We'll write the ratio in a slightly different manner this time. And to the total. So how many total seniors do we have? 310. You're pretty much done, but since they're both even, we need to get in the habit. We need to get in the habit of going ahead and reducing it. So let's divide both of them by 2, and this will be 23 to 155. That's the real answer right there. That's the ratio. Okay? Aunt Bess uses 3 cups of oatmeal to bake 6 dozen oatmeal cookies. You know, the type that nobody wants anyway. How many cups of oatmeal would she need to bake 18 dozen oatmeal cookies? Why, I have no idea, but let's just say that she does. Let's go ahead and set it up here. Do you see in the first sentence it gives us 2 pieces of information that are kind of linked together? It's usually a big clue when they're in the same sentence. Okay? We've got 3 cups of oatmeal. So I'm just going to write oatmeal right here. To 6 dozen oatmeal cookies. So I'm going to put 6 there, and I'm going to say dozens. And that's going to refer to the cookies. Okay, so this is the cups of oatmeal. It's going to refer to the dozens of cookies that you can make with it. How many cups of oatmeal does she need to make? Does she need to bake 18 dozen cookies? Well, 18 dozen goes down there on the dozen row, and we don't know how many cups that she needs. So there's our proportion. Now we just have to go solve. Well, we look for the diagonal numbers to multiply on this proportion. So 3 times 18 is 54. So let me put 54 right here. You'll notice that we got 6 kind of left over there doing nothing. So let's go ahead and use that to divide it. 54 divided by 6 is 9. So there are 9 cups of oatmeal. That's how much Aunt Bess would need to make those awful oatmeal cookies. On the map, 3 centimeters represents 150 kilometers. If a line between two cities on that map measures 4.5 centimeters, we want to know how many kilometers apart are they. So let's go and set this up. Again, a lot of times in these ratio proportion problems, not always, but a lot of times, they'll link a ratio in the same sentence. So this 3 centimeters represents 150 kilometers. So let's go set that up. Here's 3 centimeters, and here's 150 kilometers. So I've labeled them both. The 3 centimeters is actually on a map. The 150 kilometers more in the real world. And there we go. We've got this linked in. We've got our first ratio for the proportion. Now we need to go set up our second ratio. If a line between the two cities measures 4.5 centimeters, well, centimeters is on top, so we should have 4.5 on top. How many kilometers are there? That'll be x kilometers. Now we just have to go and solve this one. 150 times 4.5 is 675. And then we just divide it by the leftover 3. And we know that the answer is 225 kilometers. Chandra used 4 ounces of chocolate chips to make 2 dozen cookies. At that rate, how many ounces of chocolate chips would she need to make 5 dozen cookies? Well, we had 4 ounces of chocolate chips used to make how many dozen? 2 dozen. And then we go ahead and we need to set up the rest of our proportion. We had an unknown amount of chocolate chips going in to make 5 dozen. So now we've got a proportion. 4 times 5 is 20. What's 20 divided by 2? That would be 10 ounces. Okay? Because 4 times 5 was 20. Divide that by 2, and we get 10 ounces. So we need 10 ounces of chocolate chip to make 5 dozen. Number 7, when Rick measures the shadow of a yardstick, it is 7 inches. At the same time, the shadow of the tree he'd like to chop down is 42 inches. How tall is the tree in yards? Got a couple of things going on here. Well, let's go ahead and set up the proportion. First off, I know that we've got a 1 yard tall stick. A yardstick because it's 1 yard tall. And it's got a shadow of 7 inches. Let's go ahead and label that. That's the height of the yardstick. This is the shadow's length. Let's go ahead and set up the rest of our proportion. We don't have anything else that we need in that first sentence. The second sentence, it talks to us about the tree, and its shadow is 42 inches. So let's put that in there. And we're wanting to know how tall the tree is, so that's X yards tall. Because notice that it said it wants it in yards, so be very careful there. Let's just go and solve it now. Essentially, 1 times 42 is 42. And 42 divided by that 7 is 6 yards. So how tall is the tree? 6 yards. Ratio of boys to girls in the gym class at a local middle school is 3 to 2. What percent of the gym class is girls? This is very similar to another problem we did that was about the strawberry jam. You know, we talked about how many cups of sugar to cups of strawberries. It's almost identical. Let's take a look at it right here. Here's a 3 to 2 ratio. It is boys to girls. If we want to know percent of the girls, that means I need to know what's your representation of girls over the total amount. Well, the boys is not the total. The girls is not the total. I actually have to put these two together. What's 3 plus 2 together? 5. So the girls are 2 out of 5. We know how to take any fraction and make it into a percent. That would be the same as 0.4 or 0.40. We move our decimal over 2 times. The girls are 40% of the class. Okay. 2 more, real quick. There's a bag of marbles that has 40% blue marbles, 10% red, 30% green marbles, and 20% black marbles. What is the ratio of red marbles to black marbles? I just want a ratio, right? Here's something that's kind of cool. I don't know if you realize this, but if you added up all of these percentages, it would be 100%. And when we get that, it's kind of cool. It means that out of every 100 marbles, 20 of them would be black and 10 of them would be red. That lets us be able to set up the following ratio. 10 to 20. Does that simplify? Yeah, so just divide both of them by 10, and so our ratio is just 1 to 2. That's all that we need. Very last one. Johnny's looking at a map and measures the distance between Chattanooga and Nashville to be 3.5 inches. Wants to know the actual distance between the two cities. This part's important right here, the 1 inch to 38 miles. Go ahead and set that up right here. Now I can put my 3.5 inches right here. So here we go. Let's go ahead and write this in here. It'll be X miles apart. And there's our proportion set up ready to solve. Go ahead and multiply 38 times 3.5. You get 133 with that. And then we just divide by this 1 that's left over. Well, anything divided by 1 is itself. So the distance between Chattanooga and Nashville is 133 miles.